So we are going to start our next lecture on shift and rotate instructions. As you have realized that we have been exploring new instructions in every lecture and trying to understand different operations, which will be extremely helpful to understand the future programs and also help us writing and modifying the programs. Now we have a type of instructions called shift and rotate instructions. These instructions are completely different than what you have seen so far. Okay, so today we'll try to understand those instructions. So the first ones that we have in our list is called logical shift instructions. Okay, now there are two different kinds of logical shift. So usually the shift instructions like this one we have on our instruction set. So we have several of those logical shift. So there are two kinds, as I said. The first one is called shift left. This is the logical shift left, and the second one is logical shift right. So we have several instructions in our instruction set which are logical shift left. For an example, we have LSL, LSLA, LSLB, LSLD. Now, these are four different variants of the instructions. So, as you can guess that LSLA is actually for accumulator A, right? LSLB is for the accumulator B, LSLD is for the accumulator D, and the very first one, which is LSLOPR, is for the memory location. So basically, you can just select any memory location and do an LSL. Now, what exactly this means? This means that you will be doing a logical shift left, meaning you will be actually shifting all the bits one bit left. Okay, you might be wondering how this is possible. So what we do is we actually move, for an example, whatever we have in bit 0, we move that to bit 1. Whatever we have in bit 1, we move that to bit 2, right? Whatever we have on bit 2 goes to bit 3. Whatever we have on bit 3 goes to 4. 4 goes to 5, 5 goes to 6, 6 goes to 7, and whatever you have in 7, which is the very leftmost bit, whatever you have in 7, that actually goes to the carry. Remember, we have a flag, right? Carry flag. Now, based on these instructions, your carry flag changes. Okay? So the way the carry flag changes is, if your bit number 7 is 1, then the carry flag becomes 1, right? Because you are just pushing that to the carry. If the bit number 7 is 0, you are pushing that to carry, so the carry becomes 0. And as you can guess that we are pushing everything to our left. So what we will have in our very rightmost bit, because you actually push this one to 1, right? So basically you are pushing a 0 from outside at the very rightmost position. Okay? Similarly, when you are doing a logical shift right, you do pretty much the same thing. You actually push a 0 to your bit number 7, and every other bit from 7 to the lower order actually moves to the next right position. So basically bit 7 goes to 6, 6 goes to 5, 5 goes to 4, and all the way to 0. So basically the bit you have at the very rightmost side goes to the carry. Okay, let us see some real examples. Okay, this is the little bit of operations of the instructions, and as you can guess here, this is not a regular traditional addition subtraction kind of operation. Nothing like copy, nothing like logical comparisons. It's basically quite different than all other instructions, but these are very important. Sometimes we need some instructions like this. Let's first look at an example. Now here is an example. Let's say we are given that the content of the accumulator A is FF. So this is given to us. Okay. Now what will be the content of the indicated register, meaning accumulator A, after the following instruction is executed, meaning after this instruction is executed. Now as you can see from here, this is a logical shift right, LSR for accumulator A. Now again, just looking at the instruction, you can tell for sure this is an inherent instruction, right? So, and you can also guess why it's inherent, because it's just telling that you will be shifting one position to the right for everything that for the byte you have in accumulator A, right? So that's already, everything you need to know, you already know from the inherent mode of the instruction. Okay, so let's look at what we have there. First of all, this is given, right? So basically we have FF. Now FF means what? 8 ones, right? All ones. So we have all ones in accumulator A at the beginning. Okay. Now once we have the operation done, what happens? You are actually about to push a 0 from the left side, right? You are about to push a 0 from the left side, and then the very rightmost bit that you have should go to the carry. Now this is what happens. When you push it, this was happened. So basically you entered a 0 from the left side. Do you see it? And the very rightmost bit was actually 1, which was pushed to the carry. So after this operation is done, what is my new content of accumulator A? What is my new content in hex? The new content in hex is 7F, right? You see this is 7F, right? This is 7, 0, 1, 1, 1, and this is F, right? 1, 1, 1, 1, right? So the new content is actually 7F. So if you are given this question, and if you are asked what will be the new content of accumulator A, your answer would be 7F after you did the logical shift right. Okay, let's try some arithmetic shift operations. Now these instructions are similar but not exactly the same, but the idea is pretty same. So arithmetic shift left, we have ASL, ASLA, ASLB, and ASLD. As you can guess from the instructions, we have one for accumulator A, we have one for accumulator B, one for accumulator D, and one for the memory locations. So the idea of arithmetic shift left is pretty similar to the logical shift left. You'll be pushing a 0 from the right side and moving everything to the carry. I'm saying everything towards the carry, but this bit number 7 goes to the carry. Now arithmetic shift right is a little bit different than the logical shift right, because what happens is instead of pushing something from outside, you actually repeat this bit. Do you see it? What this means is whatever you have in bit 7, that you actually repeat. Basically this is what you do. So for an example, you have 1 in bit 7, so you actually push a 1. If you have bit 0 in bit number 7, you push a 0 from the outside. Okay, so you might be wondering why we need a logical shift left and arithmetic shift left, since they look exactly the same. Because if you look at arithmetic shift left and the logical shift left, their operations are pretty same. Okay, so the reason is both of the instructions are actually same, but the arithmetic shift left and the arithmetic shift right and the logical shift right are not same. But they sometimes try to make some instructions like this, so that they try to make it clear that one instruction is called logical shift left, another instruction is called arithmetic shift left. So they just try to make two separate, versions and keep the same instructions. But a lot of times both of the instructions work pretty same. Okay, meaning I'm talking about the left ones. The right ones are not same. Okay, now. So let's say we're given this problem. Okay, let's say we are given the content of accumulator B, which is 8B. This is given, and the instructions that we need to execute is ASRB. So basically, just by looking at the instruction, you can tell this is an instruction. This is an inherent instruction, and this is for B, right? So and you will be shifting all the bits to one position to your right. Okay. Let's see what happens. So at the beginning, you are given 8B in accumulator A, right? So this is my 8B, right? This is 8, right? 1, 0, 0, 0. This is 8, right? And this is B, 1, 0, 1, 1. So basically, we are given 8B in accumulator B. Now, we are going to do the arithmetic shift right, which means that you will be entering a 1 from this side. Why 1? Because this bit is entered, right? Once again. So whatever the bit you have at the very leftmost side, that bit is being entered again. So this bit is 1 right now. So 1 will be pushed here, and every single bit will be pushed one position to the right, and the very rightmost bit here will be pushed to the carry. So once we do the operation, this is what happens. This one is actually entered, okay, because remember the 1 was here, so we entered a 1, and everything is pushed one position to the right, and whatever you had here that was a 1, you pushed it here. So the carry becomes 1. Now this is also important to know that carry flag is being affected every time you are running logical shift left, logical shift right, arithmetic shift left, or arithmetic shift right. And interestingly, the carry flag is set or cleared just based on the bits. Okay, so this might be an exception, because remember when we talked about the flags in our last lecture, so we know that the carry flag can be set in addition operation, in subtraction operation, when we have a carry or when we have to borrow from outside in case of subtraction. But this is an exception. So there are plenty of exceptions. So I don't try to mention all the exceptions at once, but you will see the exceptions over the time. Okay. Now after we are done with this operation, what is my content of accumulator B? If you look at the content, so see the content. This is what 1 1 0 0. What is this? C, right? 1 1 0 0. And then what do we have here? 0 1 0 1. This is 5, right? 0 1 0 1. So basically the new content of my accumulator B is C5. So your answer will be just C5 after you are done with the operation. But this is interesting. There is a lot of changes, because it was at the beginning 8B, but after you are done with the arithmetic shift right, it becomes C5. See, there is not even correlation just by looking at these. Nobody can tell what exactly happened unless you see the beats. Okay. Here, remember I said this was repeated. Whatever you had here, that was. Do you see what do you have here? So you will push 1. So whatever you have here, that will be pushed. If you have a 0 here, 0 will be pushed. If you have a 1 here, 1 will be pushed. Okay. So whatever you have at the very left position, in this case, so that will be pushed. Okay. Now let's try some rotate instructions. Okay. Now we have rotate left and rotate right. Now idea is similar, but there is a little bit difference, because rotate actually rotates the whole thing. So basically what happens is, whatever you have in carry, that basically is entered from the right side, and everything is pushed left to all the way to the carry. So to do the rotate left, you actually need to know also what you have in the carry. So you need to know these, that whatever you have at the carry. Okay. So basically the carry goes all the way to the right, and everything goes one position left, and whatever you have in bit number 7, that goes to the carry. So we'll see some example. Same is for the rotate. We just do the carry all the way to the left side, pushed everything to the right, and the very rightmost bit goes to the carry. So basically you are rotating everything, you know. So, and we have 3 different rotate left. This is for the memory locations. This is for the accumulator A and B. As you can see, there is no rotate for accumulator D, right? And same is for I'm saying for rotate right. So let's try some examples. Okay. Now let's say you are given 2 different things. You are given what is the content of accumulator B. You are also given what is the carry flag, because remember, to do the rotation you must need to know what is the carry, because the carry is part of it right now, because you have to, you have to push the carry as well, right? So you need to know carry at the beginning. So that's what we said. We said the carry flag is set. That means the carry flag is 1, right? Carry is 1. Okay. Now let's see what we have. So this is what we have in accumulator B. So in the question you mentioned that we have BE, right? So this is my BE. So 1011. This is my B. So 1, 1, 1, 0, this is my E. So I have BE in my accumulator B. Now I also know that I have a carry 1, right? So here is my carry that is also mentioned in the question. So I already mentioned here. Now I'm going to do a rotate right. That means this is what I'm going to do. I'll push every single bit to one position to the right, and the rightmost bit will go to carry, and carry will come all the way up to this point, right? It's just one rotation. Okay, so we're going to start the rotation. Once you do the rotation, this is what happens. You see? Look at this. This is what happens. So you whatever you had, everything was pushed one position to the right. So you had a 0 here that was pushed to carry, and you had 1 in the carry that was pushed all the way to this left side. Now, the new content we have in accumulator B is 1101, which is D, and 1111, which is F. So basically DF. Now, again, a lot of times it's hard to understand. See, this is BE, and now we have DF. It's a lot of changes, but if you just check the bit, then you will understand what happened.
Okay, carry 0 1 would say like this.
Do you see the 0 here?
Yeah.
So you are pushing everything to one position to the right.
No, I'm talking about what if the carry was 0?
Oh, then 0 will go here. Then 0 will go here.
No, I'm talking about how the question was phrased, like how it says.
Is clear? Yeah. Clear means 0, right? Set means 1. All right. So, you know, in pause, you'll be given a question like this. All you have to tell what will be the changes we'll have in the indicated register. So the indicated register can be accumulator B, accumulator A, right? Or some memory location, okay? So these are, again, a little bit different kinds of instruction, but we still want to understand these so that we can apply this instruction and also understand the outcome of these instructions. So let's go to the quiz section, and let's try our next quiz, which is the quiz 8. This is just one single quiz, and in the quiz you'll be just given the questions based on these 4 different types of, I'm saying left, right, and the rotations, okay? So in case of left and right, you will probably see the arithmetic ones or the logical ones, but the rotations are just one kind. But even if you try to see your instruction set, remember in the column 3, we always are given some mathematical notation to understand the instruction. But this time, since these instructions are hard to explain using the mathematical notations, what they did is, if you go and check your instruction set in the column 3, you will actually see the schematic, little bit of, I would say, a little diagram which actually will have all those arrows that we have seen in the lecture. It will actually show that to understand it. And again, be careful when you will be doing the rotation instruction. You must need to know what is the status of the carry before you start the operation, okay? Because carry is also part of the rotation. Let me stop the presentation here so that you can try this quiz 8.